Hello, my name is Kristen Ortlinghaus from Griswold Controls. Thank you for joining us as we present the EPIC system. Before we talk about the EPIC system, we want to talk about the evolution of control valves in the HVAC industry in the United States. For years, hydronic systems were controlled by actuated valves, typically a globe valve style product, that controlled the flow of water to coils and other heat transfer equipment. As the system pressure would change, the flow would change, and the valve would cycle to a new position. In 1960, David Griswold invented the first pressure-independent flow control device, our stainless steel flow-limiting cartridge, and it was designed to maintain design flow regardless of pressure changes in the system. The goal was to prevent hot and cold spots in an unbalanced hydronic system. Over time, the industry started considering valves to be pressure-independent if they maintained flow regardless of pressure change, and they also had an actuated control. The Griswold controls, we were right there leading the industry since we had already introduced the MVP pressure-independent valve in early 2000. The industry started to realize that controlling delta T is the ideal way to control the heat transfer in a piece of equipment. And so pressure-dependent valves were designed that opened or closed the valve based on the delta T requirement across the equipment. So pressure changes in the system would cause a flow change, which required valve repositioning. So what is the next in the evolution of controlling the heat transfer in a coil? Pressure independence and temperature independence. And so why control based on delta T? This slide is from a previous training session we've done and identifies why delta T control is so important. The problems, as identified by U.S. Green Building Council in buildings in the United States, are wasted energy and occupancy complaints. And within the wasted energy category is the root problem, low delta T syndrome. So the core problem is acknowledged by most in our industry. Low delta T means the temperature difference across the heating or cooling equipment is low. And this impacts the efficiency of the equipment, and it also impacts the pump energy. So what is the EPIC system? The heart of the EPIC system is the Griswold Controls pressure-independent valve, and a pressure-independent valve is an actuated valve that modulates to some reduced load position, and then once the valve is done modulating and the load is satisfied, any change in system pressure does not impact that flow. And so a pressure-independent valve is important because it saves from constantly having to reposition and remodulate to a different position because there's been a pressure change in the system. And as we know, hydronic systems are constantly experiencing pressure changes as the different zones in the building are having different loads that are changing the load requirement, and as the rooms in the building are experiencing a change throughout the day, that will cause a system pressure change anytime there's a control valve change. And so the pressure-independent valve is the heart of the EPIC system. Included also in the EPIC system are the temperature sensors. And because we're measuring the temperature across some piece of heat transfer equipment, whether it's an air handling unit, a coil, there's a temperature sensor on both the inlet and outlet of the coil so that we can be constantly monitoring the delta T across the heat transfer equipment. There are also pressure sensors, so we can measure the pressure across our pressure-independent valve. And then within that, there's a flow meter with the pressure-independent valve that tells what the flow is based on the pressure sensors as well as the actuator position. And because we now know what the flow is and we know what the temperature drop is across the equipment, we can now calculate what the BTU heat transfer is for that piece of equipment. And then within the EPIC system, it's also Bluetooth compatible. So all of that information can go either to your building management system or to either an iPhone or Android device. So the EPIC system is really a group of components that work together to control the delta T. So how does it actually work? Well, the simple answer is the EPIC system measures the energy usage while monitoring the coil performance to adjust the pressure-independent valve so that it can optimize that coil's performance. So the pressure-independent valve maintains the correct flow in spite of any pressure changes and guarantees that the flow only changes when there's a demand or a load requirement change, not when there's a pressure change. The more expanded answer is the EPIC controls the valve based on the delta T across the coil. So the temperature sensors measure the delta T across the coil or air handling unit, and the EPIC controller knows to open or close the valve based on the delta T requirements. So the valve starts to either step open or step close until it gets the heat transfer equipment to the desired delta T. So what happens when the load changes? Well, when the load changes, a thermostat on the wall senses the load change whenever there's a temperature change or when the thermostat is adjusted. And this changes the coil's airflow. And as the coil CFM changes, the delta T of the water changes. And so the temperature sensors read that change, and the EPIC controller adjusts the valve to bring the delta T back to the design specification. So what happens when the system has a pressure change? Well, in delta T control product, if there's a pressure change, the system is waiting for there to read a change in delta T. But with our pressure independent valve incorporated into the EPIC system, if there is a pressure change, it maintains the same flow, so you get the same delta T across your heat transfer. So there's no need to modulate or cycle the valve to bring the delta T back in when there is a change in the system pressure. So data collection, if the EPIC system is connected to the EPIC controller, the BTU, the temperature, the pressure conditions can be communicated through Bluetooth, or it can be communicated as an analog signal to the building management system. The phone app that we have is very easy to set up. You have to hold the phone within 100 yards of the unit and click on HVAC management, and it will show either EPIC or our transducer or BTU meter devices that are within range. And you can name the unit, pick the type of product, and then the next screen is what's shown here. And so this is the data that it's sending, which is the supply and return side temperatures, and then the calculated delta T. It says the supply and inlet and outlet pressures, as well as the delta P, and then it calculates what is the BTU based on that flow rate. And it also, because the building management system can be programmed for a target delta T, it will also show what the building management system's target delta T is. So the benefit of controlling delta T, why is that important? Historically, at Griswold, we have always controlled the flow, and we have recommended that in controlling the flow, you are now impacting the delta T. And so this slide really shows the importance and how the flow rate and the delta T interact. And so you can see in the first row, we have a 2-degree delta T across some piece of heat transfer equipment. And so that requires 500 gallons per minute of water for that 2-degree delta T. If we are able to slow down the water and use less water and take it to 200 gallons per minute, you can see that we have improved the delta T to 5 degrees. And so the relationship between flow and delta T is such that if you can increase your delta T, you can decrease the amount of water that you have to pump. And so a high delta T not only is good for the heat transfer equipment and providing a good efficiency, it also can really impact how much water you're pumping through your system. So increasing your delta T will increase or will save you energy because you don't have to pump as much water. So this formula really shows well how the two interact with each other. And so historically at Griswold, we have always done flow control, which maintains the flow. And the goal was to therefore impact the delta. But now we're saying if you can control the delta T directly, we can reduce the flow requirements and heat and cool or pump less water. So you have temperature independence, not just pressure independence, but temperature independence. So regardless of what's happening in the system with temperature at other coils, the units that have EPIC have temperature independence. And within the EPIC product line, we have the BTU meter. The BTU meter has a Venturi metering station to measure flow. It also has differential pressure transducers and 2 temperature transducers so that we can measure the BTU. So the data is provided directly to the building management system, or it can be viewed on any phone apps. So BTU meters are used in applications where a building owner wants to monitor or even perhaps charge the tenants for energy. So our metering stations have been used for years for that application, but now the phone apps actually calculate the BTU because we are capturing the delta T across the heat transfer equipment. They can also use that temperature data from sensors to calculate the BTU in their building management system. BTU meters can also be used for multi-building campuses, so building owners can determine where the heating and or cooling energy is being used and adjust the controls to compensate. It helps troubleshoot high energy costs. They can see where they're losing money. They can see where they have heavier usage of heating and cooling water, and therefore extra energy for extra money for energy. So thank you for joining us. That is the summary of our EPIC system and the BTU meter. You can visit our website for more information or ask your local representative. Thank you.